Hi guys, we will talk about co collision detection. So collision or overlapping regions in in computer graphics or computational geometry, the collision or the overlapping region is just like because the two regions they share the same area. But then in commercial or in economic, it's just like the competitive region in which the two business has to compete with each other. So um, how can we detect them? We need to define the criteria first. In this case, we have everything, meaning that each customer can connect to all the shopping centers. So assuming that we define um, the region, the region in which one if you are if you are bigger than or the distance is bigger, the smaller than the other competitor, then you don't have anything to worry about. But then if like they are about the same, and then you have to consider. So that's one way to define it. The second and the simplest way would be I just select uh, my uh, my my catchment areas, and then just uh, I just overlap, or I just uh, compute the overlapping region. So let me show you the first one in which we get rid of some faraway customer, and then we compute the 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 region, the overlapping regions. Okay, so assuming that if we compute, let us compute the overall picture first. Oh, by the way, I need to show you we can actually minimize the workflow by put it in the container and then disable it. So this one is important for for uh, geospatial analysis, because there are a lot of items in the workflow. So if you run every time you run the whole workflow, it will take a long time. So you just put it in the box, and then it will be faster. Okay, so back to our question. So I will summarize my uh, catchment areas by all the points. So I don't care about uh, I don't care about the distance first. I just combine everything in the same place by the convex hull like this. Okay, so we can guess that uh, the result already, but let us show here. So this is for Chachukang, and then this is for Bishan, and this is for Bedok, and then this Dover. Okay, so basically they are the same, because this one we in here we just assume that everybody or all the customer will be connected to the to all the shopping center. So as a result, everybody in the population will be your customers, each of them. Okay, so this is not actually real, and then also not what we want as well. So let us remove some faraway customer. So I think around 10 or 12 km is okay, but then further than that, we don't shop anymore. We don't count those customer anymore. So let us see how it works in here. So distance smaller than equal to 15 kilometers, sorry, 15 kilometers away, and then we see the difference. Okay, so in here you can see 15 kilometers away from Choa Chu Kang is this thing, and then this thing is Bishan, and this one is Bedok, and then this one is Dover. Okay, so we can do the same thing at 10. So depends on your your catchment radius or the effective range of shopping, and then you can change the number. So I think for depends on the type of shopping. So for convenience store, it about 1.5 to 2 km, but then for the shopping center, I think 10, 5 to 10 is okay. It's acceptable. Uh, so this is how 10 km look like. So these are the area. Okay, let me introduce the center as well to make sure that uh, we display the two items or the two part at the same time. So this one, Bedok is here. Sorry, Choa Chu Kang is here, and then the catchment area within 10 km look like this. Bishan is here, and then this is 10 km, and then Bedok is here. Okay, and then let us move it to like 5, maybe 7, and then later we can show the catchment in order to see like small overlapping region, and then later we can compute. Okay, so there you go, and then here. Okay, so in here, if you compare the two guys like this, you can see the overlapping region is this area. Two of them like this, you can also see this one the same thing, but then three of them, it will be difficult. So how can you compute this this uh, identify all the overlapping regions in all the mall or all the store? So the answer is we just do one by one first, or pair by pair first, and then uh, we union them all together and then we have the uh, overlapping or collision for all. Okay, so let us start with pair by pair, right? So I will select the I will remove the center from the picture, and then so in order to select the pair by pair, I need to combine the the data set with itself. So I multiply one by one like it itself. So I will have to name it C1 for center one, H1 for the whole one, C2 for the center two, and H2. Okay. So after this, if you need to remove the one with itself, because we don't need those guys, right? So if the C1 different from C2, then we count it, but equal to C2, then we don't count. So let us see the result from here. Okay, so you can see here the CCK to the other three, and the other three, and then these one like CCK to CCK we don't count. Bishan to Bishan no, Bedok no, and then Dover to Dover also no. Okay, so we only care about those pairs. Now, if you want to count to compute the overlapping region between the two, the each pair like this, we have the function. So let me name it over, and then as the intersection between H1 and H2. Okay, so we will have the region, and then I have to change this one to spatial object. Okay, so in here between those two. Okay, so to be honest, I think it's very difficult to read this diagram because there are a lot of regions and a lot of things going on. So let us try to display only the overlapping, right? So let us first remove the now one, because the now one it just means that we don't have any, because they are too far away and then they don't have the overlapping regions. So I just remove the one with now. Over. And then after this, if you look into the data or look into the result, it looks like this. I want to remove the H1 and H2. Actually, we only need one of them. So I remove H2 and then we see the overlapping. Okay, so and then we do this. Actually, if you remove the H1, and then you can only see the overlapping regions like this. Okay, so in here you can see this one is the difference, the overlapping regions between the Bedok and Bishan, and then this one is the one with Bishan. Uh, okay, hold on. As CCK, where Chachukang and Bishan, and this one is the one with Chachukang and Dover, and then this one is, I think that's all. Oh, by the way, this one there's a little bit problem because this one is double counting. So A and B and the other way around is the same. So A and B and B and A. So actually, if we if you want to remove, yeah, you want to to make any computation, we need to remove the duplicate as well. So in order to remove the duplicate in this case, I think it will be very optimal to just take the unique key in here and then take the max of the. Actually, you can take the min as well, but I will take the max and then uh, actually I need both max and min to show you the comparison. Okay, so the reason I want to take the max and the mean, because they will show you the duplicate. So after this, you can see this pair, and then uh, okay, so this pair, they will be the same, but then actually they are the other way around. So this one CCK to Bishan, and this one is a Bishan to CCK, but then the unique key will be the same. As a result, if you want to, you can remove the duplicate as well. So in this case, you just use a unique tool here, and then you just use a unique key here, then and you can remove the duplicate already. Okay, so eventually you can see the only one region for each pair, and if you want to merge them all together in the same place, then you just use the summarize tool here again, and then I just make it everybody in the same place by this one. So spatial and combine. So this one will be the overlapping region again. Okay. So eventually you have something like this. Uh, so this one is one single region, but if you want to compute you want to treat each region or each cluster differently. You want to, for example, you want to compute the area in square kilometers for each of them here, then you need to break them up a little bit. So in order to break them up a little bit, then you can use the poly split here, and then you need to break by detail regions. And if assuming that you need to compute the square kilometer, you can just use the formula tool or the spatial info tool here. They are the same in this case, and you can compute the area in square km. You can extract the other thing, for example, number of parts, number of points, and other thing as well at the same time. So after you run this, you will see there are two of them here. And then uh, the area in km square, it is 62 for this one. So this one is the big one, and 23, which is almost the half size, right? Is it a half? Oh no, so the smaller than half. Okay, so 23 km square for this part, and then this one has 46 points in. So if you want the number of point is just in here, you have to count the point in the boundary. This one 19 points. So if you break this one into points, you can also count the number of points. But in this case, the function uh, count it for just. So this one just means that the whole loop is one part. So if the fragment like this, it has two parts in it, and then the count is two. But because this one is like broken into regions already, so the count is one. Okay, so that's how it works in this case. Okay, so hopefully after this you know how to compute the overlapping regions, and then when you have the region, you know how to measure the characteristic or the area or some characteristic of the region in order to to make decision on those things. Okay.